This conference will now be recorded.
Right, there we go. So we should be ready to start. So thank you very much, everybody. I'll just start with three apologies. The first one is nobody had told me this was your last event of the year, so I'm sorry you're not going out on a bigger bang, but I'm afraid you've got me. Second apology is I've told the cat he's not getting fed until much later this evening, but if he changes his mind, I might be interrupted. And lastly, slightly more seriously, my laptop isn't always 100% reliable. So if I vanish, I will be back within 60 to 90 seconds as I restart and jump back in. But that's just something I have to live with. I've spoken to IT, and there's nothing they can do apparently. Right. So I'll start with a bit of an offhand remark, I guess. So. The management of earthworks in the railway environment, it's not really about geotechnical engineering. And I think it's really important that those of us with any discipline in Network Rail remember that we're not here to look after our assets. We're actually here for getting passengers to where they want to get to, passengers and freight. And the reason I say that is that in terms of managing geotechnical assets, it's very much a shared responsibility with the track community to detect changes in the asset and make sure we work together to manage sort of emerging issues. So what I'm going to run through today, briefly, going to run through sort of I guess geotechnical management 101 for Network Rail. Very quickly, the process that we follow at a very high level to manage the asset. Then I'm going to run through a number of case studies, a couple of catastrophic earthwork failures, some progressive earthwork failures, and a couple of sites where active management and collaboration between the track teams and the geotechnical teams is essential to manage safety and performance, and then a little bit about how some of the changes that are happening in Network Rail over the next few years to further improve the way we do things. So I don't expect you to read or remember this slide. It's just I just wanted to sort of point out that geotechnical engineering in Network Rail has been its own discipline for about 20 years now, and over the last 20 years, quite a sophisticated suite of documents, standards, and processes has been established to help us do the job well. So just a couple of things that I've picked out of this long list of documents, but we've got our Earthworks Management Manual, which is Civ 086. So that's the framework within which we work to manage the asset. And then there's a couple of really key things which sit sort of under the wing of that. We've got the 065 standard, which defines how we examine our earthworks. The first module of 086, which is how we undertake evaluations. And there's a few other things here that I've picked out. Prioritization for weather resilience, and the railway drainage system manual. So drainage management, absolutely fundamental to management of both the track system, but also the earthwork system. And I know in the beginning of CP5, that was moved out of the track standards and into a civil standard. So we've got a more substantial methodology for managing drainage now as well. And then down at the bottom here, the management of reports of safety-related geotechnical incidents, Civ 185. That's sort of that's how we track all of the things that don't go so well, so that we can learn lessons and do things better in the future. So I've stolen all of these images from within the Earthworks management manual, and they're clearly copies of copies, so the text isn't super sharp, and I couldn't find a better original, but nevertheless. So this is just a pictorial representation of how we organise the railway. So we manage the earthwork asset in 5 chain lengths, and we manage them as a separate asset for the up and the down. And then we break the whole railway into 5 chain lengths, and then within a 5 chain length we'll examine all of the assets there are. So for big chunks of the railway, we just manage adjacent 5 chain lengths of embankment. But when we get into the transition of embankment and cutting, you can see on the transition here we've got a cutting on one side of the railway, embankment on the other, and then we move into the next 5 chain, and we've got a soil cutting which then transitions into a rock cutting. So we've always got sort of 2 metrics playing. We've got the number of 5 chains, and then we've got the number of and then the number of actual earthwork assets, which is the number of individual items which are examined. And this is sort of the same thing represented as a more pictorial diagram, just again making the point that the whole railway is broken into 5 chains, but within any given 5 chain, we might, for instance, here have some a soil cutting asset within the 5 chain and an embankment asset within the 5 chain. This looks a bit dull, but it's worth pointing out. So earthwork hazard category, or EHC, it's an A to E scale. It's sort of a non-dimensional number, I guess, but A category assets are those that present the lowest risk of failure and are those in the best condition. And these assets, as you can see here, for soil cuttings in a category A condition, we only examine them once in 10 years. Similarly, for an embankment in a condition A, so a good condition embankment is examined 10 yearly. And then for the other asset, and then for rock cuttings, 5 yearly, so once a control period. And then once we get into D and E category assets, so these are assets that represent a higher risk of failure, they're all examined annually. And then for the mid-table, we examine our soil cuttings mid-table 3 yearly, mid-table rock cuttings every other year, and on mid-table embankments 1 year in 5. And the reason I bring that up is just because from the perspective of the geotechnical team within Network Rail, we've got a relatively our data is refreshed relatively infrequently, whereas for the track community, information is refreshed much more regularly. So the yellow fleet, the measurement trains are running around sort of 4 weekly in a lot of locations. So if we can make good use of the information that's collected by the track teams, we get information about our embankment stock more readily than we do from our own examination process. This is a very managementy slide, isn't it? But I put this in just to try and sort of make a bit of a talk about some numbers. So across the southern region, we've got a total of 26,500 earthwork assets that are examined, sort of on the frequencies mentioned in that previous slide, of which a little over half are embankments, just under 40% are soil cuttings, and 7.4% are rock cuttings. So the railway isn't that far off, sort of 50-50 on embankment and in cutting for southern region. And due to the spread of conditions on those assets, and so with 26,500 assets on southern region, we needed to undertake 7,359 examinations in the previous exam season. So that's 28% of the total asset base. So in terms of this, in terms of this diagram, what I've sort of tried to say is if you've got your whole asset stock, you undertake some examinations. The vast majority of the examinations, they don't really tell you a great deal new, and they just those assets move back into service. If as part of an examination there's been a change in condition of that asset, so the risk profile has changed, it will trigger an evaluation. And in the earthwork sort of examination and evaluation season that we're just coming to the end of now, only 2.2% of the asset base has required an evaluation. So that's 590 evaluations undertaken this season. And just purely for interest, I guess, the examinations are undertaken by contractors that they've been delivered by Amy for the last 10 plus years. We've got new suppliers starting next season, and the evaluations are undertaken by Network Rail staff, so professional engineers within the geotechnical team. And then the rest of this life cycle here, if an evaluation sort of doesn't raise any particular concern, that asset will sort of just return to service. If it does, then the evaluation is how we identify sites where an intervention is required. If we fix the thing, it then returns to service and goes back around the loop again. Again, a very busy slide, but you don't need to sort of absorb the detail. The point of this slide really is just saying, so the EHC, so the examination output is this A to E across the bottom matrices, the bottom axes on these matrices. And then the criticality band up the other side represents the risk that asset presents to the network. So it factors in things like line speed, how wide the cess is, whether it's single line, twin, two track or four track, whether you're adjacent to a body of water that would make a derailment really problematic, or a structure where a derailment might result in a collision and all that sort of thing. And so this is the matrix that we use to drive our renewals work bank. So our worst condition, or therefore highest risk of failure assets on the right hand side, and the highest criticality, so the biggest impact if something goes wrong, means that the top right hand corner of the matrix is where we undertake renewal activity, whereas the bottom left hand side of the matrix we continue with examination. And then within the middle we've got some assets where we'll take some light touch interventions to keep them ticking along, or some slightly more sort of mid-table interventions in this refurb space. There's a separate matrices for the three different asset types, just because the different risk profiles those assets present to the railway system. So some case studies, and I really am going to have to rattle through these because each of these is probably worthy of an hour in its own right, but that's not the presentation we're doing today. So I'll really rattle through these and then sort of sum up the incidents. But this Botley Embankment failure from February 2014, so winter 2013-14 was extraordinarily wet for a prolonged period, and so a number of clay embankments in southern regions succumbed to that very long wet period. With this particular embankment, if you sort of think the practicalities of a clay embankment, it's a relatively impermeable material topped off with a very permeable track formation. So over the course of the winter 2013-14, all of the rain incident on the top sort of soaked into the upper parts of the embankment, increasing its weight. And then this particular site is founded on clay, and the particular sort of clay we've got down in this area, it's just adjacent to, it's not far away from Fareham Tunnel actually, and the clay material in this area has got very low residual strength, so once it starts to fail, it tends to continue to fail. There was also a layer of peat in the underlying geology, so as this embankment got heavier and heavier over winter, it eventually overturned quite substantially, actually, with leaving the track hanging. And I've classified this as a rapid failure. This was detected by a rough ride, and within 24 hours was sort of a little looking very much like the photograph on the left, and the photograph on the right is sort of showing us sort of a third of the way through the recovery process. So this is Epsom Embankment, which failed in December 2019, and again you can see that there's a quite substantial rotational failure. That this embankment slipped out from under the track, and I'll come. Yeah, so this one was detected by a loss of detection on the S&C. So Epsom Station is just behind the photographer in that photograph of the left, and between this location and the station there's a set of S&C, and as this failure occurred, it went out of alignment to the point where normal detection couldn't be found. Member of operations staff went out to investigate, and we were forced then to close the line. And you can see on the right hand side another very substantial repair, sheet pile wall and granular replacement of the failed part of the embankment. Again, an extended period of wet weather. The other thing you'll notice on this one is there's a number of bags of sort of aggregate knocking around on site, and this is an example of a site where there had been some movement in the embankment, which the local track team had been trying to manage, but which had not been flagged to the Earthworks community. So this is Ashmead Embankment, which is between Hook and Basingstoke, so it's on the main line. You can see from the photographs that the track is not happy at all. Again, October 2019, so another winter 19, another same extended period of wet weather. And what you can probably see, the photograph on the left is the down slow, and you've got very sort of distinctive slow or gentle drop into a low spot in the crest of the embankment, and then quite a sharp step up as the track climbs back up onto the section of the embankment that's not moving. And then on the down fast, you can see the track has moved laterally towards that failure, and that was really critical information for me and my team, that we were able to identify quite quickly looking at that the earth under the slow line was moving, and the back scar for that failure was just creeping into the fast line, which, if you can see that, it really helps sort of plan the remediation. So there's a couple of photographs of, first on the left, this is the first phase of the remediation just coming to an end. So what you can see there's a sheet pile wall in the foreground. That is the new sheet pile wall that was constructed as part of the reactive repair. And then you can see just beyond that, there's a black sheet pile wall, which is historic. And if I remember correctly, that's from a failure that occurred in the early 1980s. I think the key thing about, oh, I'm sorry, and then the photograph on the right, this then shows next phase of work. So once we'd undertaken the reactive repair to this site, we've subsequently continued the repair into the next couple of 5 chains, because the geometry and geology was all but identical, and there was signs of distress. There were signs of distress in the next sections of embankment. So this site is sort of a bit of a better news story, in so much as there was a really good working relationship between the track team and the geotechnical team. We had a planned piece of work in the workbank ready to repair this embankment. It just failed a month or so before we got to site, but we were able to maintain a service on the fast line, and the slow line was only closed for a limited period of time because of the planning that had already gone into doing the scheme that we were going to build. You're probably noticing a theme now. So this is the third site, the street embankment. So this is on the New Guildford line. And again, you can see on the left-hand side, there is a very unhappy looking dip in the track and a significant lateral displacement to the troughing route. I think it's fair to say that the working relationship between the TME that looks after the Woking and Guildford patch and the geotechnical team is pretty solid, due to the amount of challenges that the New Guildford line and the North Downs line present to both teams. But I think this is quite a nice example of where the communication between the two teams meant that we were able to identify quite early on in the development of this dip that there was a problem, and deliver an accelerated earthworks scheme that meant that we were able to continue to run a full train service through this site for the duration, other than, of course, for some weekend and overnight possessions to do project type activity, but that, you know, in planned possessions rather than needing to close the railway in an unplanned fashion. Another sheet pile wall, more complicated drainage and thousands of more tons of stone brought in, but actually quite a nice scheme from a purely from a point of interest. This was actually a really complicated scheme because there's both a culvert that runs through the embankment on the street, but there's also a high pressure gas main, which required a lot of collaboration with I believe it's Transco that operate the gas main. So we had to have seismic monitors fitted to the gas pipeline as we piled up near to it, and there's some quite substantial and clever engineering to bridge the sheet pile wall across the gas pipeline to provide us a solid base on which to rebuild the embankment. We also had a tie-in with there's a road bridge and under bridge just off the end of this photograph, so the tie-in to that bridge is quite extensive as well, and we ended up having to do a substantial rebuild on the wing walls of the bridge. So this is a really interesting site. So Bugley Bridge Embankment, BA2, so on the Salisbury Exeter line, not far from Gillingham. It's 106 miles, something like that. And this, I think this photograph, I've included this photograph because you can probably imagine that when my team and the local track maintenance team presented this photograph to senior people within Network Rail, it's quite difficult to use this photograph to articulate that we've got a serious problem on our hands, because the vegetation on the line side in this area really hides the fact that this is quite a substantial embankment, and this dip was telling us that it wasn't happy at all. So we were lucky enough to find a PhD study that was undertaken into a slip that had occurred in this embankment in 1961 and 2, and this slide shows the cross sections that the engineers who were looking at that 1960s slip drew, and we were able to verify using contemporary ground investigation that it was a reactivation of this historic slip that was causing the track to go off at this location. So you can see in the photograph on the left. So what you can actually see in the photograph on the left is quite interesting. So there's just where the silver van is parked and the area in front, you can see there's a bulge in the field, and that is actually the slip which passes under the embankment, sort of popping up in the field. And then you can see the surface, the face of the embankment is lumpy and bumpy because the 1960s work to repair the embankment, well, is sort of a bit of a misnomer, in so much as no work was undertaken to substantially rework the embankment in the 60s. What was done was a very substantial drainage scheme was installed to take water away from the slip lane. There was also a load of grouting undertaken on the embankment, but whether that did or did not help is sort of out for debate. So what we actually did on this site was, as a sort of a short to medium term intervention, the track was slewed away from the edge of the embankment, sort of into the centre of the historic track bed. So as most people are probably aware, the Salisbury-Exeter line was constructed as a twin track railway, and it was singled in the 60s. And it just happens that in this area, the line that had been retained was the one that was at the sort of the high side of the embankment because of the hill up behind us. So we were able to get a little bit more global stability out of the whole embankment system by slewing the track, and by putting a new, more modern formation in with geogrids in it and that sort of thing, stiffen it up and make it slightly more resistant to future earthwork management. More substantial work will need to be undertaken at this site in future years, and the 1960s drainage network has been rehabilitated as well to make sure that's operating as effectively as it can be. But this is an example of a site where good communication between the local track maintenance team and the geotechnical team meant that we were able to, again, run a full service apart from for a period of time to relay the track. I'm now going to jump into a couple of case studies for jobs that I don't know, as I don't know these sites as well, but they're two recommendations which are sort of worth noting for the next section. So yeah, so there was a derailment at Williston High Level Junction back in 2019, and I think this is normally referred to in the track community as Mitre Bridge Curve or Mitre Curve. But the nub of the problem here was that although both the geotechnical team and the track team were aware that there was a problem with this site, the two teams had not quite come to a common understanding about exactly who was doing what in terms of managing risk. hence the fact that further movement occurred and a freight wagon derailed, causing a fair bit of damage to the track and the S&C. And there's a whole, you know, the RAID reports are all public record. They're on the RAID website, and if you're interested, certainly go off and read this. But the sort of a couple of key points that I've picked out of this are that this chart in the top left-hand side shows twist through the site at different dates, and ultimately a twist fault occurred. And the photograph on the bottom left, as a geotechnical engineer, this is the sort of thing that I'm much more likely to be looking out for if I'm on site. You know, you've actually got evidence that a slip is daylighting in the track forefoot because you've got hogging in sleepers, you know, indicating that they're not being supported at the end nearest to the edge of the embankment. Then a cross section of the embankment on the top right, and then on the bottom right, inclinometers. So this site had been instrumented, and movement within the embankment had been monitored by the geotechnical team for a number of years. So you can see that we've got data, geotechnical monitoring information running from 2016 to 19, and a very classic trace on an inclinometer here, sort of demonstrating that roughly 2 meters below ground surface there is between 2 and 2.5 meters below ground surface there's a slip plane. This, you know, and I have sympathy for everyone involved with this job, because again, it was a renewal was planned and hadn't got there yet. The other thing that's really key on this one is that it says low speed cutout here. The track recording train stops recording data at a defined speed. It needs some kinetic energy in the system for the calibrations to work correctly, and this also occurred at the failure at Epsom. And then the last case study. So yeah, Barrow upon Soar, 2012 failure. So 2012-13 was another extraordinarily wet winter, and as can clearly be seen from this site, this embankment let go under an aggregate train, leaving the train lying on its side, and this is another example of where there was information within the business, within the track community, that hadn't made it into the heads of the geotechnical community, and there's also some parallels here with the failure at Ashmead, in that this section of railway was widened at some point in its history, so that the line that slipped, yes, it slipped under flood conditions, but there was a sort of a weakness within the structure of the embankment because of the fact that it had been widened with an additional road placed on the side of an existing embankment. The BML between Woking and Basingstoke was also constructed as twin track and then later widened to 4. So we're fairly convinced that the failure at Ashmead has partly occurred because of that embankment being widened due to side tipping. The chart on the right is just showing twist through the site. So this is my super high level summary of those incidents. So Botley and Epsom, both rapid failures. It would have been well, Botley's more rapid than Epsom, but you know, there's no hard definition. But you know, there were sorts of things where it would have been quite difficult for the business to arrest movement at those sites before things got worse. Botley, there was no knowledge within the business that site was failing. It was a rough ride, and then it was gone. And Epsom slightly less rapid. The track team did know something about it. The rest of the sites, we've had pretty good communication between the teams. So you can see if we move across to this column here, detected by, the Botley site, purely a rough ride, detected the failure. Epsom points loss detection, and then it failed progressively over the next couple of days. The rest of these sites, there was information coming in. So, you know, in addition to information that comes into the measurement trains and patrollers and everything else, we don't want to rely on information that comes in from in-service trains, but rough ride reporting does highlight us to worsening problems. Botley and Epsom, we both ended up with a line closed. And it's an error in my slide, but Barrow saw clearly the site was closed as well. And then in the last column, I've just sort of tried to flag that we've had some reactive schemes, some accelerated schemes, and Bugley Bridge is where we've had to manage the site actively. So what next? So off the back of the Williston failure, there is a change to Network Rail standards, which will be sort of published later this year, which will mandate a regular meeting between the track maintenance team and the geotech team, where and that meeting will be used to establish management plans for problematic sites. In the vast majority of the business, these meetings happen anyway, but mandating it and mandating the establishment of management plans is the real change. So that should close some of the gap on communication. This is not an area of my expertise at all, but in terms of areas where the track recording train cuts out at low speed, there's a change of standard, either recently released or imminent, to make sure those sites are properly risk assessed. And then there's some things that are going to really help what we do in the future as well. So two bits of work which are kind of they're both sort of in, I suppose, advanced R&D stage, but we don't yet have a program to roll tools out to the business for use. But we've sort of proved that it works, and more work will happen in the next few years to sort of try and systemize and industrialize it. But the first one is using track quality data from the recording trains, looking for signals in the track quality data that we can use with some confidence as precursors for failure. It's very easy to look at track quality data after a failure and said, yeah, you could have seen that. But actually, if you don't have quite sophisticated analysis, actually you end up with a lot of false positives, which we don't have the capacity to deal with multiple false positives. And then the next thing, which looks like it's got some real potential, is we've now got really good LiDAR data for most of the railway flown in winter, so the vegetation is off, is at its minimum, and we've been able to prove that if you take LiDAR images, so it's a model of the ground is created using laser scanning from an aircraft. We can use sort of machine learning to compare images in LiDAR data collected at time intervals, and then those images can be compared and movements highlighted for further investigation. So that is it. That is all I've got to say. So I've now finished. Andy, I guess you need to take over chairing.
Thank you very much, Hector. So some fascinating insights there into the Earthworks world, and it's over to the audience now. If you'd like to ask any questions on any aspects that Hector has raised there, on the management of the Earthworks asset. Now's your chance, and you can either raise your hand and ask a question after you've turned your microphone on, or you can type into the chat as Paul Ebbott has done. So we'll start off, Hector, with a question from Paul Ebbott. And Paul has asked, design of embankment sheet pile walls. I recall back in around 2000 on Transport for London, we had a policy of installing castellated embankment sheet pile walls. Do you have any comment on this?
Can I sort of add to that, Andy? That's all right, because
Yes,
it's a long issue, and they were castellated into the ground, I was sort of on the approval side, and that seemed to be a policy at the time. And I've got a feeling that continuous sheet pile walls were not liked at the time. So I'm just interested in what your design philosophy has been with all these sheet pile walls. And I think it's something about allowing flow of water or something between the two sides of the sheet pile. Any comments?
Yeah, so I know that there is an arrangement of sheet piles, which is sometimes referred to as hit and miss, which I'm guessing is the same thing. Its use was licensed by one of the big piling contractors, so they'd sort of patented that arrangement of sheet piles. So without paying a license, and I'll be entirely honest, I don't know the full details, but without paying a license to, it was developed for works undertaken on the M25, and it may or may not have been Balfour Beatty's that hold the license for undertaking sheet piling of that nature. So dealing with groundwater under the embankment is absolutely something that needs to be factored into the design, and we also need to factor in water which falls on the embankment and then could become trapped behind the sheet pile. The relative importance of groundwater and water within the embankment is considered on a site-by-site basis. On nearly all of the sheet pile walls that we've installed in the last sort of 5 or 6 years, we've put a granular drain behind the wall with perforated pipes and then formal outfalls. But that's not really dealing with the subsurface water. But I know certainly for one of the jobs we had in the New Forest, subsurface water was a significant concern. There's quite a lot of modelling was done to demonstrate that was or wasn't a problem, which is almost answering the question. Yes, we think about it, but no, it's not a technology we tend to use.
Okay, thank you.
Thanks very much. A question from John Gribble, Hector. Have you had any recent embankment fires, and what's been the impact of those, if you've had any?
So there have been in summer 2018. There were some embankment fires in parts of the country with historic coal mining, and there's very occasionally embankment fires that are related to peat. The geology of southern region doesn't really lend itself to that, and it's a long time since anybody's mined any coal in this patch, so it's not an issue we've had. We do, of course, occasionally.
In the past, there've been issues with embankments that have been built or extended using ash being tipped.
Yes.
And that then can give you the grief if you haven't got the coal mines around. I remember in the past having to persuade the fire brigade not to squirt water on an embankment because it was on fire, because all it does is produce more gas that then burns even more.
But yeah, we've not had any substantial fires in the 10 odd years I've been knocking about.
Okay. Yeah.
Question from Ian Ross. So Ian, actually, can I invite you to unmute yourself and ask the question in person?
Yeah, no problem. So it was just following on from the tragic events in Cumbria. is that likely to lead to a change of the inspection frequencies and your the Earthworks categories?
So there's several things going on in this space in terms of workforce safety, and there's a real challenging balance to be struck between managing asset risk and the safety of people undertaking work on the railway. So in terms of asset risk, we are actually shortly going to be going live with a new algorithm that sits behind the earthwork examination for embankments, which is likely to increase the number of examinations that need to be undertaken. But of course, the safety of people undertaking those examinations is of paramount importance. Southern region is moving to stop the use of unassisted lookout working, and by a fluke of timing, the contractors that undertake our earthwork examinations, our new contractors actually start at the beginning of next month. So we do need to sort of, I guess, take stock and ensure that we're able to mobilise our new contractors before we make a substantial change in the way work is delivered. But there's several projects going on in the business to try and make sure people on site are much better protected and supported to deliver their work safely.
Thank you, Hector. Peter Halliwell, would you like to ask your question?
Well, hi, thanks, Andy. That was a great talk. Thank you very much, and a great reminder of the processes for managing earthworks. I was interested on how your estate is faring. What are the trends in the EHC? Are things improving with the durable interventions that you've made? And are you beating the natural degradation of the rest of the earthworks from the weather and load?
I think there's probably two answers to that, Peter. The first one is that the volume of renewal that we're currently undertaking is a little less than we need to hold sort of global conditions stable. So there is a slow degradation in global condition. However, I think our risk management tools are better now than they've ever been, and therefore we're able to target work better now than we have in the past. So we're probably more confident now than we were even a couple of control periods ago that where we are spending our money on renewals, that it's absolutely in the right place. But yeah, one of the most challenging things for the geotechnical teams, and no doubt for plenty of other teams in Network Rail, is assuring themselves that the work that we can't afford to do doesn't present an uncomfortable level of risk. And certainly after the derailment and tragic loss of life in Scotland last year, there's going to be a renewed emphasis on management of drainage, which will improve safety in cuttings.
Thanks very much. Can I move on to Dave Merritt's question, please? Dave, are you able to unmute and ask your question?
Yeah, sorry.
Oh, you're welcome.
Unmute button. Right. Yes, I'd, post the Scots disaster that you just touched on, public statements were made to say NR will never let a repeat happen. Given your point when you were talking about some of the failures, that actually we were only picking those up when track movements were taking place, what more needs to change to actually achieve that goal?
So I I am quite involved in the national response to the failure in Scotland, and obviously there's still a live police investigation ongoing. So there's a whole load of information. So there's an interim report has been published by RABE, which is purely factual, which anybody again can go and take a look at. And so I need to be slightly cagey because I've probably been party to conversations internally, which need to remain internal until police actions undertaken, etc. But I think one of the key things to take note of in Scotland is that was a failure in a cutting, which and the failure was driven by some extremely intense rainfall. So there's a couple of work streams which have been pushed quite hard. One is that there's been some very sort of rapid turnaround work undertaken to improve the way that we use forecast information. So when we get really heavy rainfall forecast, we have an alerting system. So our control room staff are alerted to these intense rainfall events, and there's been a change to one of the operation standards, which then means that information is passed on to signallers and trains can be slowed down. So I think that's a real game changer in terms of risk management. And there's another piece of work ongoing which is looking to significantly improve our understanding of small catchments that direct water towards the railway. So there's absolutely scope to do things better. And as I mentioned, the last sort of 2 bullet points for the presentation, we've also got this sort of advanced R&D project looking at track quality data and using sort of machine learning to seek out signals within that data that indicate precursor for embankment failure. And the last one, oh sorry, I've just remembered the differential LiDAR information. That would require some investment. We'd need more regular LiDAR flights, but the technology is now the technology has been proven to work. So that is something the business is looking to make greater use of to make sort of systemized use of in the future. And there's also some tools which are quite well advanced but not quite rolled out into the business, which is looking at the makeup of our embankment stock and its vulnerability to sort of mass movement, which again that tool's sort of ready for use, but the way we access that information is to be rolled out later this control period. So there's a lot of activity happening to try and improve our business processes to deal with this stuff.
Yep, thank you.
Good stuff. I'm going to exercise chair's privilege as well and just ask a question that's bugging me, if that's all right, Hector. So in your response to the different levels of criticality that you get from your inspections, you explained about policy interventions which would include maintenance or would include refurbishment and then renewal for the highest criticality sites. Could you just give us an idea of the sort of relative costs per metre of intervention by renewal versus refurbishment and maintenance, and what sort of refurbishment and maintenance options are open to you on embankments and cuttings?
Yeah, absolutely. So at the bottom end, the most simple maintenance activity is just vegetation maintenance, so that we can so that we can do a really good inspection of the asset. And we depending on the size of the site, we sort of budget between about 2,000 and 5,000 a year for that sort of intervention. Yeah. next level up would be monitoring equipment installations and maintenance. So we budget for, I think it's about £6,000 per year, and then a more substantial investment in sort of equipment renewal every 7 or 8 years. The unit rate for a refurbishment. So a refurbishment would be, typically it would be a line of gabions, rock-filled baskets, covering less than 20% of the total length of the site. So if you've got a small discrete slip, that can be repaired with some tow weight and a bit of a regrade, and that might probably talking sort of, I don't know, between 60,000-70,000 up to a couple of 100,000, and then your renewals. See, that one of the real challenges is because of the way we manage our earthworks by 5 chain length, and our embankments are our embankments and cuttings are everything from sort of 3 meters high or deep up to kind of 30+ meters high or deep, depending on geography. We end up with something like a 3,000% range in the size of a renewal job. So some of our renewals would be a regrade on a sort of 3 or 4 meter high embankment, which might only be a couple of 100,000. But then we've also had some very substantial embankment renewals with very substantial sheet piles and back of wall drainage and various other things that have crept into the sort of £2.5–3 million per 5 chain range. That's right at the top end. But southern region is at the more expensive end of the range for delivering work, partly because of limited access to the network, limited access to third-party land. Got quite an urban railway. The Epsom failure was quite expensive to fix because we had to replace a set of S&C and demolish a commercial garage to access the site. So yeah, there's a lot of third-party costs at some sites.
Thanks very much. We've got a couple more questions on the chat. One from Bob Hazel. Bob, would you like to ask your question?
Yeah, excellent presentation. Thank you for that, Hector. Most of the presentations or examples that you gave of failures were on embankments, and I just wonder what the relative risk is to the operational railway in terms of failures on cuttings against failures on embankments. So I have to say I am familiar with most of those sites that you've shown, and it's I don't know if it's frustrating that they're still failing after sort of previous interventions, but it's reassuring that the work you're doing now is hopefully going to put them right.
So that's quite a complicated. Question, Bob. So it's more common for cutting failures to result in a derailment, and that's because the rough ride reporting is quite, it's absolutely not what we want. It's absolutely not what we want to rely on to alert us of a developing problem. But the fact that quite small displacements in the track are evident either to the track record and train, or if that doesn't pick them up in time to in-service trains, it means that it's really relatively uncommon that we go as far as a problem that results in a derailment on embankments, and so the relative risk, it's greatest for rock cuttings, because almost any failure in a rock cutting can lead to a significant derailment risk, just because any material that finds itself on track is very, by its very nature, it's hard and can't easily be pushed out of the way by trains. Cuttings soil cuttings are the next level of risk, and embankments we nearly always fix them before we end up in a line closing situation. And there is a little bit of a regional variation there, because the southern region has soft geology. We don't have an awful lot of opportunity to do sort of light touch interventions on our embankments. Once our embankments start to move, they're going to continue to move unless we really fix them. So, which is why there's so many images of sheet piles in the presentation. Whereas for our cutting sites, there's quite often a lower order intervention that can be undertaken to significantly improve the risk profile, even if it's not going to have as long a life as a full fix.
Okay, thank you.
Thanks very much. Colin White, a question about the filthy lucre.
Thanks, Andy. Thanks very much, Hector. That was a great presentation. I was on that line between Guildford, goes up towards Reading, and I did see the earthworks. The works have been done over the past couple of months, and that look really impressive. But I did think to myself, well, these are probably not things you've been planning to do for years. These are you have to intervene quite quickly on that. And what happens if you've got loads of parts along the patch which need these major interventions? Surely, sort of what happens? Because I assume there's a pot of money to do all of this, and what happens if you've just got loads of areas that need work in a similar time frame? How does that manage? Like, is there a sort of emergency pot within Network Rail, or how does it work?
So our minor works contractors do formally have an incident, you know, a reactive element to the contract through which they're employed. So if we get a small cutting failure, and it's basically a case of picking the muck up and getting it off track, our minor works contractors are, you know, that is in their contract to provide that service. For the much bigger failures, we rely on capital delivery and the framework contractors, but it's a real challenge, and it makes it very difficult to deliver planned work efficiently when you need to continually mothball planned jobs to move staff onto reactive schemes. But I think probably a lot of people on this call will appreciate that the railway attracts some interesting characters, and the commitment to get the job done is something we probably over rely on. There's some of our contractors have you know, absolutely sworn that they'll be at home with a family next Christmas, and then when the next failure happens, they're back out on site. So yeah, there's some real superstars out in the teams, in the routes, in ops, sort of arranging possessions at short notice, in capital delivery, sort of getting contracts out and managing projects through the winter season, and in the supply chain, people really going above and beyond. It's a real challenge, because the whole industry is really, you know, geared to work around our sort of 2-year possession planning timescales, and trying to squeeze big capital jobs in with no notice is really challenging, but the supply chain does seem to be able to rise to the occasion.
Yeah, thank you.
Good stuff. And just one more question from Peter Halliwell, who wants to ask a bit more about the relationship, Hector, with engineers and examiners and so on. Peter.
Hi, thanks, Andy. Clearly, there needs to be a very good relationship between those who are looking after the track and can spot when it might start to go off, and those who are managing up the surrounding earthworks. I just invite you to comment on how effective that is for your patch.
Yeah, I'd say it's really pretty good, and yeah, you know, it's always a little bit challenging when there's a bunch of people sort of move roles and people need to sort of get to grips with their new job and then rebuild those relationships. But you know, I run the Earthworks team for Wessex for 5 years, and I knew all of the TMEs, and the engineers in my team knew all of the section managers, and some of the section managers, we saw them more than we wanted to. But yeah, I think the working relationship certainly within Wessex route and across Southern region is strong. You know, my personal view, which is purely a personal view, and I don't have evidence to back it up, is that I feel that sometimes in the two really big routes, you know, not now Northwest and Central and Eastern region, that were sort of high 20s of TMEs each, and a single Earthworks ram to look after that patch. I think that made those relationships harder to maintain. But I think in Southern region, I think we've done a pretty good job.
Good stuff.
Thanks.
I think that is actually a really good point on which to stop. If I could just sort of pass on Paul Ebbott's closing comment. Paul says, excellent presentation and discussion. Thanks very much, Hector. Addressing key hazards for the railway infrastructure. You've given us a really fascinating talk this evening with really good illustrations, and I was a rather jaw-dropping photo of Botley, which I hadn't seen before, and absolutely enormous scope of work there, and it's so different from the scale of intervention now is so different from the sort of scale of intervention that I remember sort of seeing as a young engineer training way back in the 80s, where one particular favourite of mine was 3 track panels piled one on top of another and then backfilled from the top with ballast. But
that's on the Reading line, isn't it?
It could well be, yes. It's standing the test of time.
Yes.
But the interventions that you've described here are clearly highly designed and engineered, and should be securing the railway for many years to come. So thank you very much for your presentation. Thank you very much for answering such a wide-ranging group of questions, and thank you very much, audience, for supplying those questions as well, and that greatly added to the interest of the talk. So thanks very much, Hector. If you'd all like to take your microphones off mute, then we can give Hector a proper round of applause, even though we're a virtual meeting. Thank you very much.